Hi, everyone. My name is Patricia Loria. I am a Senior Client Engagement Lead at the Global CCS Institute. This is a two-day event, so I assume many of you were here yesterday. But for those of you who are only attending day two, thank you very much. We have an exciting continuation of our program from yesterday. Just a reminder, this program is sponsored by the U.S. Department of Energy, the Office of Fossil Energy, the U.S. Energy Association, and the Global CCS Institute. The goal is to assist project developers, emitters, landowners, interested parties in Texas in developing CCUS projects there. We had an exciting and we think very kind of practical conversation about this yesterday with individuals who are incredibly knowledgeable about the state of Texas, including a great introduction from Leslie Savage of the Texas Railroad Commission. You can see our program there from yesterday. If you did miss it, that will be recorded and put on our website. Today we have a great agenda as well. We're going to start with some case studies from companies doing projects in Texas now. We'll move on to challenges to deployment in Texas and strategies to address them. And then we're going to move into our breakout sessions. We'll have 3 breakout sessions. Those we will have separate links to join. Those links are currently in the chat box, but we will be walking you through that kind of at the end of our group session on day 2. We hope that you will continue to engage through this session with questions. We had some great questions yesterday. You can add your questions to the chat box that you see on your screen. But in the breakout sessions, you'll be able to ask your questions directly. This session is being recorded as day 1 was as well. And if you look at kind of the screen, you should have opportunities to customize your viewing, whether you want to see all the speakers, see the webcams, take a screenshot, etc. We certainly encourage you to reach out to myself, Jeff Erickson from the Global CCS Institute, and all the other speakers. Connect with us on LinkedIn or directly. We're here to kind of help you get your projects started, and really excited for the opportunities for CCUS in Texas and beyond. So let's get started with these case studies. The first up is going to be Moji Karimi. He's the CEO of Sambita Factory. Next will be Damian Beaucamp, who's the Chief Development Officer for 8 Rivers. And then we'll have Tony Catone. He's a Senior Director for Strategic Development at Axie Low Carbon Ventures. Tony is having some video issues, so you'll only be hearing his voice, so don't think that you're kind of missing something. Okay, and I will pass it off to Moji.
Thank you, Patricia. All right, and are you sharing the screens, or you want me to do so?
No, Sonia, if you want to go to the next slide and maybe turn on his video.
All right, thank you so much. So today I'll be talking about some of the projects that we're working on. These are projects that come to fruition within the next few years. So probably a bit less mature than some of the other projects that will be discussed today, but nonetheless, this is a different category of CO2 utilization projects in the pipeline that leverage advancements in synthetic biology for using CO2 as a feedstock. Can you go to the next slide, please? Yeah, so just to add a bit more context before we talk about the specific project, basically what we have done at Sambita is to create a portfolio of microorganisms that we engineer to be able to use CO2 or methane as a feedstock. So these are basically microbes such as cyanobacteria that are photosynthetic, could use light as a source of energy, CO2, water, same as plants do photosynthesis process. But we go in there and we engineer the genetic pathways so that we could produce other chemicals other than sugar, which is the case for classic photosynthesis. And so these products are going to be carbon negative, of course, because we're using CO2 as a feedstock. And just like in nature, these processes happen under ambient pressure and temperature. So you're not going to have a lot of energy requirement to keep the heat up. to run the reactions. And so this is just to give you more context. The overall vision for Cemvita is to create these pathways to heavy industries, including downstream oil and gas and petrochemicals and chemicals, as a pathway for low carbon energy transition for them. And it would allow us to use CO2 as a kind of a valuable resource, a feedstock, instead of a waste and a liability. If you go to the next slide, please. So to sum this up, basically, we're turning these microbes into small advanced refineries that run under ambient pressure and temperature. A lot of this, as you guys know, has already been done in the field of synthetic biology for pharmaceutics, for high value specialty kind of molecules, chemicals, and nutrients, cosmetics, fragrance. And now we're bringing that into, CCUS applications and using CO2 as a feedstock. Next slide, please. Now let's talk about very specifically this project that I want to share, that most likely we will utilize 45Q once the first plant is up and running. This is a project that we're doing in collaboration with Oxy. The goal here is to produce carbon negative bioethylene using CO2 from the flue gas as a feedstock. We have completed phase 1 of this project. Now we're doing phase 2, where we're scaling up the reaction. We have done the techno-economic assessment using assumptions from the client, in this case Oxy, and what we see is that we could utilize about 1.7 million tons of CO2 per year from the flue gas of a cogen power plant to then produce 1 billion pounds of bioethylene per year. This is a pretty small size ethylene plant. As you guys know, typically they're 3 to 4, but because the design is modular, actually you could then ramp that up from there. The important thing to note here is that the cost estimate that we have as of right now is actually indicating that it could be 30% lower than the current cost for producing ethylene through a hydrocracking process. It is lower for a few reasons. One is that we're eliminating ethane as a feedstock. Also, as mentioned, these reactions happen under ambient pressure and temperature. And in nature, these microbes and enzymes, proteins produce specifically what they're supposed to produce. So you're not going to have co-products, and that what that means is we're going to have a very simplified post-processing process, which also saves a lot of cost. With regards to 45Q, this project qualifies for the utilization part, which is about $35 per ton of CO2 utilized. For this project adds up to about $60 million per year. We have not included that in the techno-economic assessment that we do, and that 30% that I mentioned. But nonetheless, this is a driver for this project as well, and using CO2 as a feedstock. Now, this is just one example. There's other molecules that we're working on that would utilize CO2 as a feedstock. Most cases, our ideal scenario is to use the CO2 from a flue gas, which would have been emitted otherwise. But we're not limited to that. We could also use CO2 from, a DAC system, or from biogenic CO2 from fermentation process, and other sources of CO2 as well. And next slide, please. And just to this is my last slide, just to add a bit more flavor to some of the other projects that we're working on, what we call subsurface carbon utilization. So in this case, basically that refinery that I mentioned, we want to take it in the subsurface. So turn the reservoir into a refinery, basically. And in this case, those reactions we want to do with microbes that we know could thrive in the subsurface. A lot of the learnings here is combining what we're learning from CO2 utilization with the legacy of microbial enhanced oil recovery, and then mix that with what we're doing with CO2 enhanced oil recovery. And that would get us to what we call subsurface carbon utilization. That goes beyond use of CO2 for EOR and just pushing the oil out, but to actually use the CO2 as a feedstock in the subsurface. That allows us to use more CO2 in the process. It also helps overcome some of the geological limitations of CO2 sequestration by converting CO2 into other molecules, which then could be stored in the subsurface. We have other projects in this area as well, both intended for the Permian Basin and then also for offshore. But we're doing early phases of this project, so of course a lot of testing had to be done with core samples first to measure the effectiveness, and then field trial and beyond. But I hope this was helpful. This was a general view of how at Samvita we're thinking about using CO2 as a feedstock. I'm happy to answer any questions that you might have, and feel free to reach out. My email is moji@samvitafactory.com if you have other questions. Thank you.
Hi, and we'll go on to Damien. We'll be taking all of our questions at the end of the session. So we'll run through each of the panelists first.
Thank you, Patricia, and thank you everybody who's joined this webinar. My name is Damien Beauchamp. I'm the Chief Development Officer at 8 Rivers Capital. At 8 Rivers, we're developing solutions that help assist any organization that has committed to net zero by 2050 achieve those ambitions profitably. We develop solutions ranging from the energy sector, the agricultural sector, and the industrial sector to help decarbonize. We don't develop a single widget. We develop total industrial solutions that allow a customer or organization or government to achieve lower emissions to zero emissions profitably. Some of those technologies that we've been developing are things like zero emissions power generation from natural gas, negative emissions power production from biomass, post-combustion carbon capture for industrial effluents using a technology called carbonate, as well as purely electrically driven direct air capture, net zero LNG, and zero emissions ammonia production for both the agricultural sector and as a hydrogen transport medium. We also have developed zero emissions blue hydrogen production at sub $1 per kilogram prices. Texas, I think, offers a unique and substantial opportunity for projects like this. Currently, our work in project development in the state, because in addition to technology development and licensing, we also do develop some of our own projects. Currently, we're developing a project to bring CO2 into Texas, though the facility is not located in Texas. I think it's important, a project like this in a session such as this, because it demonstrates Texas's ability to anchor surrounding states as a CO2 sequestration hub, given all of the experience of all the oil and gas companies within Texas, especially Occidental Petroleum, who's taken a significant leadership position, not only in Texas, but globally, and has probably the most experience of any organization in handling and managing CO2 in a very safe and environmentally friendly manner. In addition to bringing CO2 from one of our power generation projects outside of Texas, we're looking at a quicklime production facility, which inherently will capture its CO2 and sequester that CO2 while producing valuable calcium oxide for the cement, soil stabilization, and steel industries. Also, on the coast within the Gulf, we're looking at LNG facilities and how those can be decarbonized using solutions like net power as well as carbonate. Further, we're looking at using existing chlor-alkali facilities that may be turned down due to recent economic times due to COVID and disruptions in the oil and chemicals business, and utilizing those facilities as methods to capture CO2 directly from the air at a profit instead of a cost. Those are some of the main projects that we're looking at in Texas today. We're having quite a bit of traction on all of those. We're also seeing firms outside of the typical energy and industrial sectors getting involved in projects, especially those from the tech sector, those being the Googles, the Microsofts, and the Amazons. And there are various business models in addition to technologies that can allow for the participation of those types of organizations in lowering their CO2 footprint, while at the same time reducing the cost burden on the main project developer or owner, if you will. We think these opportunities are very exciting, and we are even more excited by the fact that private industries are making these commitments without substantial government regulatory push for them to do so. And with that, I'm happy to pass to Tony from Occidental's Oxy Low Carbon Ventures to get his take.
Thank you, Damien.
Great, thanks, Damien, and thanks everyone for joining today. It's great to be on this panel with Damien and Moji, and really sharing the progress and innovation that's occurred over the last couple of years. And there's a lot more to come in the space. Really, as Damien and Moji were saying, Oxy is a leader in the space, and we'd like to continue leading the innovation in the space. Really, where it's come from is this unique position that we've had in the oil and gas business called the enhanced oil recovery business, which is situated in the Permian Basin in West Texas. And what we have here is a really unique position. This business essentially utilizes CO2 through its operations. We're sequestering 20 million tons per year of CO2 through these operations, and that CO2 gets permanently sequestered in a reservoir. Now, we've been taking naturally occurring CO2 to do that for the last 40 years, but our whole goal is to replace all of that naturally occurring CO2 with anthropogenic CO2 and atmospheric CO2 as well. And so this has given us a really great platform to build these types of businesses, to work with Damien, to work with Moji. So that's really the core of what's going on here. The project that I want to talk about though today, it's called Project Intersect. This is really the model project for industrial CO2 capture, I would say, in Texas. It's sort of the standard carbon capture project that you would think of here. So this is a partnership between U.S Energy. U.S Energy is a biofuels manufacturer in Texas, ethanol specifically, and Oxy Low Carbon Ventures. This was first announced. This was the first announced project really after the passing of the Enhanced Future Act, which enhanced the 45Q tax credits. So we've been developing this project with U.S Energy in Texas for a number of years. I'd say that there are thousands of man hours into not just the sort of engineering of this capture facility, but also on the commercial negotiations between the emitter, the capture facility, as well as the sequesterer. So we'll talk more about that. But this project, it's going to capture 700,000 metric tons of CO2 every year off of the 2 ethanol facilities where we'll build capture facilities. That will then be transported by 2 separate sort of lateral CO2 pipelines that will connect into Oxy's network in the Permian Basin, where we will utilize that CO2 in our enhanced oil recovery business. What this does is, by capturing that CO2, it reduces the carbon intensity of that ethanol very materially, and so it's a great climate story and great climate strategy for any type of biofuels company. The CO2 will be stored and validated by an EPA-approved monitoring, reporting, and verification plan. This is what you really need to do to get the 45Q tax credit. Oxy was a leader in this area as well. We had the first 2 approved MRV plans with the U.S. EPA for our Denver unit, which is an enhanced oil recovery unit, and the Hobbs unit as well. What I should also say here is that we're also going to be storing the CO2 under the California Air Resources Board sequestration protocol as well. And so that gives the ethanol facility a pathway for that lower CI. And so this project will also generate low carbon fuel standard credits in addition to the 45Q tax credits. Can we go to the next slide, please? That's it. Did it flip to the next slide because it's not showing up on mine? Okay, there we go. Great. So this is a schematic of how this is really going to work. Like I've been describing, there's 2 ethanol facilities. What you probably heard yesterday, if you were a part of the sessions, is that there's certain emitters that have high concentrations of CO2 in their emissions. And in this case, ethanol produces a biogenic gas. You're talking about approximately 95% CO2 out of the stream. The remaining bit is oxygen and water. And so physically what the CO2 capture plant in the middle is going to be doing is a dehydration process to remove that water, and then a liquefaction process really to remove the oxygen. So the gas streams are cooled to be liquefied, and then a distillation tower will separate out the oxygen from the stream, and that's going to produce the pure CO2 to a pipeline, the 2 pipelines that I mentioned that will go directly to Oxy's EOR operations. I think it's worth noting, while we talk about innovation in the space a lot, this CO2 capture plant, this is a mature technology. It's been deployed many times in the ethanol industry already, really to produce things like dry ice, which is made of CO2. Like we've been mentioning, in between here, you have the joint venture partnership. This partnership is being funded by the sponsors, which are White Energy and Occidental Petroleum. So this is the quote unquote cash equity that's going to be going into this structure. The total project is approximately $150, $160 million of capital. The remaining the balance that the sponsor won't be putting in as cash equity, we are marketing to tax equity investors currently, and are close to finalizing a transaction that's probably going to be the first of a kind CCUS 45Q sort of project financing here. A tax equity investor is going to come in, provide upfront capital, and then will be allocated the income losses and tax credits at a very high percentage versus the cash equity sponsors in the structure. Once they meet a specified yield on their investment, they will flip out of that economic position, and their income losses and tax credit allocation will go down to a low percentage. That's in general how these partnerships work. I'll pause here, and we can, I think, go to questions as well.
Yeah, and why don't we leave this slide up, because we do have a couple kind of questions that are specific to this project, and this schematic might help that, Tony. So the first one, I'll ask a couple. So there was a question about what CO2 capture technology is being used here. Is it amine based? And then also, who's claiming the 45Q tax credit, White Energy or Oxy? Is it split? How is that decided?
Yeah, so the actual technology here, like I was saying, it's a liquefaction technology. It's not an amine technology. So you would use that amine technology with other emitters, mostly post-combustion, and something like a coal plant. Here, you're dealing with a more pure stream of CO2, upwards of 95%. And so it's easier to separate that out. And so you're using you're essentially removing the water from the stream through a dehydration unit, and then the liquefaction is cooling those streams, liquefying the CO2 and oxygen, and a distillation tower with the various sort of boiling points or temperatures will separate out that CO2 and the oxygen. What also is in this capture facility, so the CO2 needs to be transported and also injected into reservoirs at sort of a high pressure. So we're talking above 1900 PSI. So there's a great deal of pressure and compression required at the capture facility. For the second question, in this joint venture, the CO2 capture plant is getting the 45Q tax credits. That's in general how the regulations are written, except for when that is contractually given to the sequestration operator. But in this situation, we're sort of on version, I said this yesterday, so version 1.0 of getting these tax equity partnerships done. And the preference is for the tax equity partner to own the physical capture facility. And so that's where the 45Q tax credits are getting generated and monetized.
And then one more question specific to this project, and then we'll kind of move on to some more general questions. How long are the CO2 pipelines from the plants? Were they existing pipelines, or did you have to build them for this project?
Yeah, so for this project, the CO2 pipelines coming out of the capture facility, those are going to be built. And so there's going to be two of them, approximately 40 to 50 miles long. I believe one of them is going straight into really an injection operation. And then the other one is going into our long haul pipeline network. I believe it's the Sheep Mountain long haul pipeline, which it's either Sheep Mountain or Bravo pipeline, which will transport that to sort of our central locations. Those pipelines are in existence today.
Great. Switching back gears to some questions we got, Moji, for you. Are there any restrictions in terms of the CO2 purity stream as feedstock for the metabolic process? And then there was also some questions. You talked about costs of $30 to $35 per ton, which is generally seen as almost lower than the cost of traditional flue gas capture. So the question was a bit about which technology are you using for the capture side of your project? Emoji, you're muted.
Yeah, sorry. Not the first time this happened this year. Yeah, I think these two questions that actually kind of have one answer, and that is part of the benefit of using this kind of biological system is that they could directly use the flue gas. And they're not as sensitive as, say, catalyst to different purity streams of CO2. As a matter of fact, even when we have NOx and SOx in the gas, which is common, there are some species that could use that as nutrient for the process, and they kind of find their way to evolve to be able to manage the different variation. And so because of that, we eliminate the cost of capturing the flue gas, separating the CO2, things like that. We could directly use the flue gas in that process.
Great. And then another question for you, Moji. How sensitive are the Cemvita bacteria to oxygen?
So it depends what, if you're using aerobic, anaerobic, what's kind of the reaction, because we don't have just one species. It's a portfolio of different species that we use. If you don't want oxygen in the reaction, then of course we have to deal with that, and we have for some cases really the issue is more around having oxygen next to a volatile compound at the scale, which is not a good safety measure. So what we've done in those cases is we separate the reactions into two reactions, where in one of them we produce a kind of an intermediate and oxygen, and then we use that intermediate in a second reaction to then produce the end product. So if we're using microorganisms that could exist next to oxygen, that should not be a problem. But in some other cases they are, if it's anaerobic reaction, so we have to manage that differently.
Great. Next, I'm going to turn to a question that it was asked specifically for Oxy, but I'll kind of put it out to all of you. On estimate on the number of jobs that will be created for some of these projects. And so the question was kind of first in the construction phase, and second for the operations and maintenance of these plants, or their estimates of jobs. And I just wanted to kind of say at this point, there actually just came out, I think last week, but it may have even been this week, it's been a long week. Rhodium Group did a report on jobs from CCS. They'd previously done a report of jobs kind of that could be attributed to direct air capture plants. So I would encourage everyone to go look at that report. It's a great report. But for all the panelists, do you have kind of any information or estimates about potential jobs being created?
Yeah.
I don't. Go ahead, Dan.
I can kind of touch on that from a industrial complex perspective, and then perhaps maybe Moji can touch on that for his. And then for Tony, I think what starts to make sense is, you know, once that CO2 is captured and then it's going into a pipeline, if there are new pipelines need to be built and sequestration facilities needing to be managed, maybe that's a reasonable flow that I'll suggest. But for us, on a typical, so if we look at one of our subsidiaries, Net Power, during the construction phase, we see average sitting around 500 construction jobs at peak construction. And then as that scales down into operations, kind of support staff for the facility sitting anywhere between 11 to 22, depending on the circumstance, the size of the complex, if it's integrated with, say, ammonia production or LNG production. If we look at some of our other systems, we're looking at, for carbonate, peak construction staff sitting around 100 to 150, operational personnel sitting anywhere from 10 to 15 for those facilities. And I could go into other estimates, but that's what we see. And then if you take that as a multiplier across all the CO2 potential and all the CO2 needing to be captured from now until 2050, I think that gives you a strong sense. But that's our perspective on it.
Tony, do you have thoughts on that question?
Yeah, absolutely. And sort of the data that I know offhand, because I've recently worked on it, is in an example would be a long haul pipeline, right? So sort of a pipeline that would you know, create a corridor across the state of Texas, let's say. So you know, 1,000 or more mile pipeline, something like that, a large scale project that would be you know, over $1 billion of capital, that would create, you know, over, you know, 2,000 to 3,000 sort of construction and engineering jobs during that, you know, multi-year project, and then sort of 40 to 60 type permanent jobs for something like that. And so the scale is quite great when it's to sort of creating and supporting GDP. Obviously, you know, the goal would be to have multiple long haul pipelines that would be sort of collecting CO2 across the U.S. and head it to sinks to be sequestered. Obviously, the project that we're talking about here, it would be smaller scale, but still talking, I believe, off the top of my head, you know, hundreds of jobs and probably, you know, 10 or 15 permanent type jobs to run the facilities.
Great. So, you know, we got a question yesterday and kind of a question today about direct air capture. The question yesterday, Tony, was about the carbon engineering project with Oxy and a status. So if maybe you could give some update there. And then there was a question, Damien, to you about your direct air capture project. And Tony, maybe do you want to, you know, I've certainly seen other projects about, you know, the carbon engineering project. Maybe just give a sense of what that project feels like in terms of kind of size and scope, and, you know, how it may be different than this schematic, you know, we put on for the Intercept project, and then just kind of give an update of how that project's going.
Yeah, so I'll give a little background. Yeah, sure. I'll give a little background here. So when Oxy was looking at the CCUS value chain, we really saw direct air capture as a really important technology for really decarbonizing society. I think what's probably least understood, right, is that in order for us to be successful and really reach sort of a true net zero, we're going to need to take CO2 stock out of the atmosphere. And there's only so many scalable methods of doing that. And we believe that carbon engineering's direct air capture technology is the most scalable technology out there. There's a number of different types of technologies. Oxy was really informed by our current business as to investing into carbon engineering. The reason being is really what we looked at is the base chemical that is used in the process is KOH. Oxy's the largest producer of KOH perhaps in the world, and so really what we saw this as was a large chemical plant, right? And this is something that Oxy is really good at deploying and deploying rapidly and multiple times. And so what we saw here was the ability to marry this capture technology with the pore space that we have in our enhanced oil recovery business, right? So I mentioned 20 million tons of capacity in the Permian Basin. And so we sort of saw ourselves that we needed to deploy this technology, scale it up, and get it down the cost curve. What we really like about the technology is that it's actually already at industrial scale, meaning that the component parts of this process, the calciner, the slaker, the air contactors, there's already a supply chain behind it, right? And so I sort of liken it to Tesla identifying the lithium-ion battery as the technology to go with. They recognize that there's a bunch of computers, there's a bunch of iPhones out there and other types of phones that use lithium-ion, and so they were going to be able to draw from the supply chain that technology and get to economies of scale. And so that's similar way of how we think about that technology, being able to draw on the supply chain and be able to get the cost curve down for that technology. The technology is supported by the LCFS credit plus 45Q, as well as what Oxy will pay for the CO2 as a raw material. So as we've announced, we've plan on deploying upwards of 1 million ton plant in the Permian Basin here over the next couple of years. Probably went into too much detail there, Patricia, but
no, I think that was helpful. Damien, do you want to talk a little bit more about the 8 Rivers projects with DAC?
Yeah, absolutely. So when 8 Rivers agrees, and I agree with Tony, direct air capture is extremely important. And because we see it as so important, we've developed 3 real sectors or pillars for direct air capture. The first is through bioenergy with CCS, using our patented Allen-Fett cycle to consume biomass that has pulled CO2 from the atmosphere through photosynthesis, use that biomass as a sustainable fuel stock, and then capture that CO2 on the back end through a company we call 8 Rivers Energy. Then we look at passive direct air capture. So when calcium oxide, which ultimately through a direct air capture process is converted to calcium hydroxide, to produce that calcium oxide, a significant amount of CO2 is emitted today, a lot of CO2. And so we've developed a process to produce calcium oxide at 0 emissions, such that we can then use that calcium oxide in what we call passive direct air capture. We currently are partnered with MIT on developing a full commercial scale unit that uses a commercially available clinker and basically uses the calcium oxide, the hydrated calcium oxide, to passively capture CO2 from the atmosphere, capturing all emissions along the way. Specifically in Texas, what we're looking at is a direct air capture process that is purely electrically driven. It doesn't require, like other direct air capture processes, any thermal input, no fossil fuel. So if you had a pure decarbonized grid and you used this chlor-alkali direct air capture process, you would need no thermal input. All you need is electrical energy. And instead of using calcium hydroxide in this case, we look to exploit sodium hydroxide, which is produced at a certain step in a chlor-alkali facility. And we cycle between sodium hydroxide and sodium carbonate. And we use a simple precipitator. By changing temperature of water, we can precipitate out that sodium carbonate and then produce it. And we think that's interesting because the chlor-alkali industry is quite large and can support a significant amount of these projects, yielding direct air capture at a profit instead of a cost. At the same time, we're also able to implement this solution on existing chlor-alkali facilities for direct air capture purposes by bringing in private equity and tax equity partners who are interested in pulling CO2 out of the atmosphere, as well as, say, if you look at a company who operates a chlor-alkali facility, they can also then monetize some of the CO2 capture benefits from a project like that. Specifically in Texas, we're looking at the latter two, a passive carbonate type process where we capture the CO2 passively, meaning there's no mechanical components in the capture process. And then a purely electrically driven direct air capture process through chlor-alkali retrofit, capturing CO2 at a profit.
Great, thanks. We've had several questions on 45Q, whether or not these projects would exist without kind of the tax credit. Also kind of back to Oxy's answer, if White Energy is just getting the tax credit, what's in it for Oxy? So do you maybe want to talk about it? Emoji, you can talk too. I know that some of your projects will benefit from 45Q, but certainly utilization potentially has some opportunity to exist outside of 45Q. Talk about kind of the importance to the tax credits for each of your projects, and you know, if given that the tax credit, you know, is only on projects that start before a certain date, Congress may change that. How do you think about projects kind of beyond 45Q?
So maybe I'll just make one comment, and hopefully this is not too controversial given the topic is 45Q. But when we do these projects, we think of it as, can we create a better way of making this chemical that is going to be more cost effective, regardless of tax benefits? When the tax benefit comes in, for us, that's more like a bonus, basically, for our clients. Of course, it's a big driver for them to, like, fund these projects, build the first facility and everything else. But for us as the technology company, we're almost 100% focused on, can we create a better way of making this chemical using CO2 as a feedstock instead of what they're doing today? And that's where really we spend most of our energy. But we collaborate with them to the degree that we could build a project, to have that kind of 45Q benefit in mind, and how that impacts the economic kind of tornado chart that we built, and where the revenue is going to come from, things like that. But for us, we mostly are focused on the techno-economic assessment.
Damien or Tony, do you want to talk about kind of 45Q and the importance of that to your projects?
Yeah, obviously 45Q provides a substantial economic incentive to enhancing the economic return from any carbon capture project. At 8 Rivers, our objective is to design carbon capture processes, facilities, and solutions that are not dependent on any government subsidy and that could be fully justified purely on the economic basis of existing equipment, existing supply chains, and that is our objective. That's our objective with our direct air capture technologies. That's been our objective with things like the alum FET cycle, as well as carbonate. Carbonate, for example, if you build it, it does capture its CO2. It can deliver that CO2 for sequestration, or more importantly, even utilization. And it can do that just on the sale of its calcium oxide alone. Needs to do nothing more. And we think that's important. There are ways to develop existing solutions. And the way we see it is it can't be that we're developing specific widgets that do one single kind of capture. That really tends to elevate the cost. It needs to be a generally integrated process using existing processes, existing equipment, and existing supply chains. I think that is kind of the trifecta for maximizing the economic return from CO2 capture. But 45Q, LCFS, more of these kinds of credits, obviously very important, and will certainly make carbon capture accelerate in the marketplace.
Yeah, I absolutely agree with both Damian and Moji here, and I think they gave really good examples of projects that stand on their own, and that's certainly where we want to head. I would say for the project that we showed here, it is supported by 45Q and that subsidy, and so it would not happen but for that tax credit. On the other side of this, though, essentially what you have is the LCFS credit that's also getting generated here. You know, I actually don't consider the LCFS credit a subsidy. I actually consider that as their transportation program in California, that you know, the emissions are being penalized, and so others that can generate credits are being incentivized. And so essentially the customers in the state of California have decided that they wanted a lower carbon intensity fuel, and that's what we're providing to that market through the sale of a lower CI ethanol. And I think that the trend will be heading in that direction.
And if I could add to what Tony just mentioned, I realized I forgot to add in, there are other incentives that we found as through our project development arm. So we've built into 8 Rivers a full broker dealer, and that allows us to kind of sell financial products, if you will, in the marketplace to various financial investors. And we think this is an important component to the business model aspect of CCUS. And one other way that anybody developing carbon capture processes could look at enhancing their economics and incentivizing investors to come in is through opportunity zones. So depending on how a project and where a project is located, if these opportunity zones where capital gains can be parked tax-free for a particular number of years, this will certainly incentivize, as we've seen, many large investors to come in and use their financial means to support project development. In addition, there are things called hub zones, which if you're working with the government or providing power, say, or material to the government, where you can get an enhanced bidding opportunity when selling into the government through hub zones. So looking beyond just the carbon credits, if you will, into the total economic and tax credit incentives. We also like things like 48A. Those can really create some magic in projects, those three things on top of 45Q and LCFS.
Great. Well, we are actually at time for this program, and I think it's funny, we could have just transitioned at this point to the future of financing and the support of financiers for clean energy. But I think that's really hopeful as well. But with that, I will say thank you to this group of panelists. This has been a really exciting conversation. We are certainly going to have the opportunity, you'll have the opportunity to talk to Tony more directly in the breakout sessions, and excited to interact more fully with you there. But thank you, Moji, Damien, and Tony for this really informative session.
Great.
We're going to move on to kind of our last panel session here for the day before we go out to our breakouts. And this is challenges for deployment and strategies to address them. And we have 3 speakers joining me here. So we have Brett Logue, who is a principal at Elysian Ventures, Adam Peltz, a senior attorney at the Environmental Defense Fund, and Ken Medlock, who's at Rice University. He's the James A. Baker III and Susan G. Baker Fellow in Energy and Resource Economics. Thank you all for joining us today. I'm going to start with a question for Adam. As I said, he's from the Environmental Defense Fund, and so we haven't talked much about what environmental NGOs kind of think of CCS. I think we had a couple questions on that yesterday, but certainly would like to hear first, Adam, that environmental NGO perspective. And I know that you've done a lot of work kind of thinking about CCS deployment, thinking about geological storage of CO2, and how to do that in a way that ensures we're helping environmental considerations and not hurting them. So would love to hear your thoughts there.
Great, and can you hear me? Am I all set? Okay.
Yes.
So thanks. Thank you, Patricia, and for having me, and my co-panelists. It's good to see you guys. And Patricia, I especially like your candle. So the Environmental Defense Fund is engaged in all manner of energy issues, and we recognize that carbon capture and sequestration has a very important role to play in climate mitigation over the next several decades. One of the issues that we're tracking that Patricia has prompted me to talk about is stakeholder acceptance of CCS. And so I wanted to raise some not red flags, but yellow flags for people to contemplate of what might be coming on a state and a national basis. Within the environmental community, especially among climate activists, and really especially among the environmental justice universe, there is a lot of skepticism about CCS on grounds that it is, and you'll have to excuse this, but a perpetuation of the fossil fuel industry on the one hand, and for environmental justice movement, a perpetuation of dirty facilities that are poisoning their communities, et cetera. And so there is, that is true to some extent, and it is also untrue to perhaps a greater extent. But it is something that needs to be reckoned with, especially considering that, notwithstanding the conversation we just had about subsidies, 45Q and LCFS are very important to a lot of people who are developing projects, and their ongoing existence will depend on support broadly from across the country, and it's an area where environmental activists and EJ activists will have perhaps increasing sway. And so there's a number of antidotes to that. One is through a lot of stakeholder outreach and meeting these communities and these groups and talking. That's really important. But some good policy to help facilitate the continued acceptance, or the acceptance really of CCS, is for projects and the regulations that govern them to have environmental integrity, which to us means no leakage of CO2 to the atmosphere, no contamination of groundwater, and no earthquakes. So those are all important. Those are things that can be demonstrated to show that this is this is real, that the CO2 that's being put underground really stays there and isn't causing negative externalities. And then, another component, I know this is going to come up, is on liability. And we have some concern about what calls for transfer of liability for CCS projects to the state means in terms of sort of how the public sees the safety and reliability of this technology. But we can perhaps get into that bit later.
Thank you. Absolutely. And we had a little bit about that question yesterday as well. I'm going to ask you one more question, and I'm happy to have kind of Ken weigh in on this one as well. We've heard about Class 6 well permits and other regulatory rules required for this carbon management infrastructure. And do you think both the federal government and potential state governments who are looking for primacy really have the skills and resources to conduct this role? And is that a concern for environmental NGOs?
Well, it's certainly a concern for us, and we would like to see both the EPA and regulators in states that are either have or are considering taking on primacy to really take a hard look at whether they have the sufficient regulatory capacity to oversee these programs at the scale that's been envisioned. I mean, Class 6 wells take a lot more regulator input than any of the other classes, maybe except for Class 1, and it requires skill sets that don't necessarily currently exist within oil and gas regulatory agencies right now, especially with respect to long-term modeling, CO2 transport, and all of that. And so there is a need for more funding for the EPA itself and for agencies with primacy to be able to staff up, hire third-party consultants, be able to know whether their third-party consultants are telling them things that are right, in computer systems for modeling, and more inspectors and so forth. And so making sure that the regulators who are overseeing this are up to task is a key issue for us.
Ken, do you have any kind of perspectives on these Class 6 well permits and what the state can do?
I do, actually, and I don't disagree with anything Adam just said. It's critically important for any regulatory oversight measure that you have the appropriate staffing and capability in place. And that's without a doubt true when we get to a discussion about Class 6 injection wells. I mean, there really aren't any in Texas yet, but there's certainly designs to move that way. The issue of primacy is one that is, I think, going to be addressed very quickly. I think you probably heard about that yesterday a little bit. But at the end of the day, once jurisdictional clarity is provided, if that actually is forthcoming in the next legislative session, whichever agency has oversight, it's incumbent on that agency to make sure it has the appropriate staffing and accordingly the level of funding necessary to make sure it does its job correctly. So those are, when we get to those kinds of issues, they're ultimately addressable. It's still important to point them out, but they're definitely addressable.
Why don't we, I had a set of questions here, but let's kind of follow this conversation a little bit on the liability issue, because we didn't really touch on that yesterday, and I had some questions outstanding. Ken, do you want to talk about, Texas perspective on liability for kind of CO2, and I don't think that that's as addressed as maybe states like Louisiana who have kind of made proclamations. But maybe what some of the thinking is on the state on kind of liability, post-well closure, et cetera, and where you think that could be going. And then Adam, happy to hear your thoughts, and then Brett, bring you onto the conversation, because certainly I know from a project developer standpoint, open questions on kind of liability certainly could be roadblocks to implementing a project.
So yeah, happy to kind of get that kick started. And I'm sure Adam and Brett can add a lot of color to this discussion. Just for context, we've been leading a working group for about 1.5 years now, with a lot of different stakeholders that are really interested in scaling up the use of carbon capture and storage, or carbon capture, utilization, and storage. Sort of both dimensions are in play in the state of Texas. A heavy focus on the Gulf Coast, because the Gulf Coast in Texas, as you know, is massive industrial complex, significant source of CO2 emissions that, if aggregated, could lead to a significant reduction in the CO2 footprint if it's all captured and stored successfully in the state of Texas. So a lot of interest there. A lot of different issues have come up in the working group, and liability has definitely been one. It has been recognized regardless of the stakeholder. So when we talk about stakeholders, we're talking about folks who would be perhaps utilizing CO2 for enhanced oil recovery, companies that are in the business of transportation, so pipeline firms, as well as firms that would be involved in the capture phase. So full value chain, if you will. To an individual, everybody's agreed that liability is an issue that needs to be addressed, but there really isn't unanimity with regard to how it should be addressed. So it's an issue that is still an open issue in the state of Texas. It's something ultimately that could be addressed legislatively. Not sure if it's going to be taken up in the next legislative session, given all of the things that are on the docket. But it is certainly something that we're elevating through the work that we're doing in the discussion to hopefully get some addressment. I am an economist, a resource economist. So when you look at full value chain development, you realize that this is, when you talk about developing carbon capture value chains, it's a massive coordination problem. And if there's a hiccup anywhere along that value chain, it can create an obstacle to development. So liability is definitely one of those potential obstacles, and it does need to be addressed. There's a variety of opinions on this. I think the only place where it's actually addressed is in state offshore facilities, which there aren't any right now, right? But the General Land Office has the ability to permit pipelines and injection wells, and post-site closure, I believe, in the Texas Code, it takes over liability within a year of closure. All that said, I know there's resistance even to that. But one of the counterweights, and I think this is actually important when you get into a discussion about the commercial prospects of doing these things, which the liability issue certainly fits squarely in the middle of. When you talk about state lands, so state offshore, if you're leasing pore space, that actually, for long-term CO2 storage, that actually does generate a revenue stream to the state. The education fund actually receives funds for that. So that kind of tilts the discussion in political circles. I know we've had a lot of discussions with, various policymakers in Austin on both sides of the aisle about this, and that's actually something that raises eyebrows. So I think it's something to watch, and it could actually, if things were to move quickly in terms of offshore development, there's a lot of other obstacles in the way, don't get me wrong, but if things were to move quickly, that could actually set a precedent for how liability ultimately is going to be addressed. But I think that's, again, a story that's still being written, and I know there's a lot of disagreement over how it should actually be handled.
Brett, why don't I go to you next, and then we'll let Adam talk. From a developer perspective, and you might want to give some introduction about projects that you've been looking at in Texas. How big an issue is this liability issue to kind of getting projects up and running, in your opinion? And what is your kind of perspective on what could be better answered?
Well, I mean, I think the key to most of these projects has been discussed repeatedly is the 45Q credits. And the 45Q credits, in order to be able to get value for them, you need to have a taxpayer and tax equity in most cases, as Tony talked about that structure earlier. And part of I principally have sort of finance and before that legal background, have been involved in project finance in the renewable space for better part of a decade, and involved in tax equity transactions there. And I think the tax equity investors historically have been extremely risk averse. I mean, we sort of jokingly refer to them as super senior debt, They're basically debt with higher return expectations, and they have very little tolerance for risk. And the liability piece, is something that in here is a very new component related to the ultimate storage of CO2. If you think about solar or wind, in both of those applications, you may have challenges in terms of projecting, the resource going forward. But once the wind blows or once the sun shines, I mean, that is, the end of it for, the establishment of the credit. You don't have, issues of recapture. You don't have issues of the sort of ultimate, storage responsibilities, and you don't have really, the same kinds of perspective sort of fear around those releases. And so, I agree with Ken. The liability, writ large is sort of, something that, is a recurring theme, and finding the right home for it. The sort of risk associated with, some of those aspects is a key part of the structuring. I would say, on the more kind of optimistic side, I think from the science point of view, there's, and this was talked about yesterday as well, there's much less concern about, ultimate emissions or leaks of CO2. We've looked at the sort of, and this is why Texas is, such a key, market to initiate a lot of these projects in, because there's probably the longest sort of history of dealing with CO2 in Texas. A very good understanding of its impact, related to the geology, and you've got basically 40 years of experience. And so I think you can kind of draw on that, plus the DOE, has now for decades been, supporting, definitions around this. So I think the sort of space is well positioned to be able to resolve this, but I think you've got a lot of people coming up the learning curve, especially people who, are essential to the transactions like tax equity, who have to initiate themselves in a space they really are unfamiliar with, and that departs in meaningful ways from solar and wind projects. And so it poses some challenges, but, I think it's ultimately sort of resolvable.
Adam, do you want to give your take on this liability conversation?
Yeah, and so, for us, liability relief is really a tricky double-edged sword, because for one thing, there's a tension between CCS proponents saying, we know what we're doing, this is a great technology, it's going to work, it's going to save the climate. On the other hand, the state has to take all the liability because we have no idea what's going to happen. So that definitely creates a public perception problem. And there's also a moral hazard that's introduced with liability relief, because you want the project developers who have most control over risk to have that risk hanging over them so that they do a good job and forfend against the calamities that liability relief would protect against. And if you take that away, then you have more of a pathway for bad acting, which could bring down the whole show. And so, for that reason, we're really cautious on liability relief, and we like the approach in Wyoming, which is if you break it, you pay for it, and that does have an appeal. There are certain state mechanisms that do partial indemnification under certain circumstances, and so we think that any liability relief should be limited in that fashion so as to not trigger these dual harms of sort of a public perception paradox and moral hazard.
So real quick, I'm going to add one thing, and maybe you have some thoughts on this too, actually. Some of the discussions in our working group have ranged from, liability post-site closure being infinite to liability post-site closure being handed off instantly to the state, to there really doesn't need to be any sort of legislative solution here if you let a market develop, right, an insurance market. And you know, I've actually had some interesting conversations with people in the insurance industry, and they've indicated that at the current moment they wouldn't touch this with a 10-foot pole because there's just too much uncertainty about what it means, and it's an unknown variable, right? So when you sort of factor all those things in, you begin to understand why this is one of those. It may be one of the trickiest issues actually when you think about full value chain development and how policy intersects with it, but it's certainly an issue that, again, I'll just say it again, it's going to need to be resolved to see this carbon capture really happen at scale in Texas. And certain states are out in front on some of this stuff. You know, Adam mentioned Wyoming. I think they've got some pretty creative sort of approaches to this, but you know, hopefully there are legislative approaches that can be sort of indicated by what other states have done. So.
Well, and I mean, I think one of the interesting things about the U.S. and having basically, 50 plus the federal sort of jurisdictions, as it provides some opportunity for experimentation around what works, and you'll probably see, something of a land rush if someone gets it right, in other locations. But I think the chief challenge around it is the sort of, I think the long dated sort of liabilities can be, a real challenge around the structuring, especially, for projects that if you're doing, direct disposal of the CO2 and you're expecting to have a kind of time limited capture facility, and ultimately at the end of the 45Q, are potentially sort of wrapping up the project, you want to be able to sort of, tie a bow on that at some point, and not, necessarily just, be hanging around for in the case of California, the 100-year, time frame, although that's been, modified to some degree. I think the approach within the 45Q regulations of having that, if you can think of the recapture as being somewhat like, related to the ultimate sort of liability. I mean, that having it time limited at least gives you, a way of sort of structuring the relationships within the transaction, and having that sort of certainty, an infinite sort of timeline that, is particularly difficult challenge to structure around. But even, it doesn't have to be an immediate handoff, as long as it's sort of a defined sort of transition to some I will say that we were sort of kind of hopeful that there would be some insurance or insurance derived sort of product to sort of handle it. It's still something that's obviously in discussion, but as Ken notes, there's not a whole lot of excitement about taking that on right now.
So around 10 years ago, EDF, Southern, Zurich, and Duke Energy came up with an idea of how to do a phased transition where perhaps the first 80 or 100 projects would have some kind of liability state relief nexus, and then that would be enough, we had hoped, for a commercial market to see what was going on and develop, because after all, if, as what we all say is true, the risk is not that great, and so there's nothing.
Should be a profit center if that's true.
Exactly, and people still build bridges and skyscrapers, despite lots of long-term liability, and there are common law statutes of limitation too that come into play.
Great, and we'll move on from this conversation. I will put it in the chat. The Institute actually will be having an event on liability. It'll have more of a global perspective. Ian Haverkoff from the Institute wrote a paper on liability last year. Scott Anderson from EDF will also be on that kind of conversation, as well as Shell. So I'll kind of put a link to that in the chat. It's actually not up and running yet, so I'll kind of show you where it will be on our event page. But yeah, we're obviously not going to solve this conversation on this call, but there'll be some other resources on liability.
Well, another 15 minutes, Patricia. I mean, anything is.
What did you say, Brett? I'm sorry.
I said there's still another 15 minutes. Anything is possible.
Yeah.
So kind of back to, I said I had some regularly scheduled questions and I diverted a little bit, but Ken, We talked some yesterday about other, I would say, Texas issue. Pore space and mineral rights is certainly one of them. There's resolution over legislative authority, whether the Texas Railroad Commission has that. Can you talk about some of those other issues and where you think the priority is from a legislative perspective in this next session for addressing some other kind of Texas-related challenges?
Well, I think, probably the most imminent issue to be addressed is going to be that jurisdictional clarity. So who actually does have, regulatory domain over Class 6 injection wells? Is it the Railroad Commission or TCEQ? In general, I think there's a leaning towards the Railroad Commission actually having that function. I fully expect that that's an issue that's going to be resolved very quickly. Beyond that, it's difficult to say with any clarity if anything else is going to get addressed in the next legislative session. Actually, it's just there's so much going on. We've had numbers of conversations with different lawmakers, and it always comes back to when we get to the addressment of commercial certainty. Is there any sort of fiscal support that can be lent from the state that maybe could leverage 45Q or build upon it, something of that nature? And there's reluctance to engage in that at this point in time, just because there's so many other issues, largely sparked by COVID. So we're sort of in a unique time. I think everybody knows that, right? Budgets at the state level, certainly at the municipal and county levels, and large cities, they're strapped, and it becomes very difficult to have an engaging discussion on fiscal support for a long-term investment. That's unfortunate, but it's also one of the reasons why the state offshore waters idea that I floated a minute ago has raised eyebrows, because it's been viewed by some policymakers as something that generates a long-term return to the state. So it would be viewed in that context as an investment rather than just fiscal support for something. So, that's something that could potentially get some attention. I'm not high on it actually seeing any sort of legislative movement in this session. When we get into, pore space ownership and access to pore space, we get into, there's been discussions raised about unitization of CO2 storage rights specifically. Unitization in the state of Texas is a tough discussion. It's been raised before, and there's been legislation introduced, but it's never gone anywhere. And so there's a lot of reticence to trying to bring that up in this legislative session, just because there's so many different things on the docket. That said, that's addressing mandatory unitization. It doesn't mean you can't, get into voluntary provisions where you negotiate with different landowners. And I mean, that happens with regard to oil and gas extraction already. So thinking about it happening for CO2 is certainly something that's in play, and that doesn't require any legislative oversight, anything from the Texas legislature. So, I actually think, because we've had some conversations with large landowners, I actually think that is something that there's a runway for, because some of the large landowners that that we've spoken with are actually very high on figuring out ways to monetize storage rights to the pore space that they own. So it really then just becomes about negotiation. So I think we're going to have to see some creativity on the side of industry to figure out actually how to monetize or create a monetary value associated with CO2 storage that's attractive to landowners, because there's certainly a lot of opportunities. I think Brett mentioned the geology in the state. It's tremendous, right? And I think that actually bodes very well for those types of negotiations. But in terms of legislative solutions, I don't know that much is going to happen in 2021 other than jurisdictional clarity.
Great. Brett, maybe I'll go back to you. I think you talked some about some of the advantages of working in Texas, and we had some of these conversations yesterday around pipeline challenges, some of these issues on pore space versus mineral rights, and maybe people in Texas get that. better than they do in some other states, which makes enabling some of these projects easier. What are some of the things that make Texas kind of attractive from a project developer standpoint? And maybe kind of the converse, what are some of the things that maybe you think other states do better that make them more attractive for projects?
Sure. I mean, as at Elysian, we're principally focused on project development. We are technology agnostic. We are looking at and working on post-combustion capture on power, at capturing at industrial high concentration facilities, and so we are more focused on those kinds of questions around how do we get a development done, how do we move from idea to actual implementation as quickly as possible. And we have the advantage of and Keith Tracy was on here as well, but having team members who have worked on developing CCS projects. I realize I've been involved in one way or another in CCS now for 11 years, and I was sort of shocked to realize that. But I think in terms of Texas versus other states, I mean, the attractive part about Texas is that you can build things here, and oftentimes quite quickly. There's a lot of transparency, not just in terms of the rules, but also quite a lot of information available, that are relevant to projects in terms of potential off-takers, potential uses, sort of concerned around right-of-ways. All of that stuff is relatively easily accessible to be able to evaluate and quantify the challenges related to projects. And that varies, as I said. You've got there are advantages of having 50 plus district jurisdictions in the United States. There are definitely disadvantages, because in a lot of ways, you move from state to state and you're relearning, from scratch, how to execute projects. So I think, I mean, one issue with Texas is it's been so supportive of especially sort of pipeline. If you ever look at a pipeline map, it is just spaghetti thrown on a plate. And so sort of finding your way through, it's sometimes a physical challenge as opposed to a regulatory one. I think, one of the things that other states, potentially provide that are more advantageous is some, additional incentive. So, for California, you have the LCFS program. Maybe that gets expanded to additional states, principally, probably, Western states. That's a real sort of material advantage and for projects. I don't think that the pricing is going to stay where it is forever, but I think it'll still be strong in incentive. And on the other hand, California is one of the most difficult places to develop projects, and citing concerns, and oftentimes you can't really even anticipate what people are going to be concerned about. And so that side of it, although there's a lot of sort of governmental support and a lot of potentially financial support there, there's still real challenges to implementation. I think some of the other places, Wyoming has been at the forefront in terms of trying to help facilitate project development. Louisiana has, North Dakota. I mean, I think these are all sort of places where there's definite interest and work being done to try and accommodate and facilitate project development.
Thanks, but I think that was really helpful, and it kind of brings up, a question. And I work with Adam on California as well, and certainly, community acceptance there could be an issue on projects. But without putting you on the spot for the whole environmental NGO community, Adam, there was a question asked, how come environmental NGOs aren't more supportive, given, the IPCC report saying that we're going to need this number of facilities, CCS facilities, to stay below 1.5 degrees. We tend to use IEA estimates, which say that we'll need 2,000 facilities by 2050 2,000 large-scale facilities to meet their sustainable development goals. Do you want to speak to what you see potentially as kind of changing perspectives on CCS? Do you think, you know, the environmental community is becoming more supportive, and, you know, using a little bit of a crystal ball, you know, do you think that could continue to kind of change? Obviously, the United States is in, you know, a challenging position in kind of an election year that could have effects on all kinds of kind of clean energy infrastructure bills, but just looking at your kind of opinion on changing dynamics.
So I think one thing that's going to be important to change the dynamic is to piece apart the different flavors and permutations of CCS, which I think for a lot of environmental groups, it's stuck in their head as coal plants to EOR, you know, as opposed to like DEC to saline, for example. And perhaps not, many groups don't even realize that there's this giant spectrum of things that you can do with CCS, and it's really a suite of technologies. And so, you know, piecing that apart and talking about, well, here's where CCS plays a role that has nothing to do with the fossil fuel economy, and does not perpetuate the fossil fuel economy, I think will be helpful in getting some more support, as opposed to having just a blanket, no, we think this is bad, this is not the right approach, let us do all renewables instead. And so, you know, having more conversations that are subtle and technical with increasingly large groups of stakeholders, I think will be really critical to getting to more widespread support, and especially for local communities, to show that the benefits of CCS will in fact accrue to those communities and not just to equity investors halfway across the country.
So I want to add something to that, because I actually agree with Adam that engagement is critical on this front, because there is, and I've seen this in various conversations I've had, a misunderstanding with regard to what we're talking about when we talk about carbon capture technologies. One thing that is proven in a lab, it still has to be scaled and proven commercial, and there's a lot of material science innovation that needs to happen. But when we think about, you know, a hydrogen economy that is coupled with carbon capture, you actually have proven technologies through pyrolysis combustion, which is an oxygen-starved combustion where you get carbon black and hydrogen. And carbon black can be used as a feedstock in a number of different carbon nanofiber technologies. So we're getting into a nanotech discussion now. But you can actually develop, and again, this is where we get into material science, but you can develop things that have varying tensile strengths that can be used in place of steel in certain types of applications. And now you're talking about competing with an industry that is very energy intensive through a set of innovations that leverage carbon capture at its very core. So when we start to think about those things, lightweighting everything, that actually has benefits for energy efficiency, has benefits for energy intensity as well, in terms of producing building materials and auto bodies and all sorts of other things. There's all these things on the horizon that are sort of frontier research and development things that are already being done in a lab that I think also need to be communicated, because when we talk about the future of carbon in general, right, it doesn't look the same as it does right now. It looks very different, and it gets into an entirely different array of how we actually think about consuming energy. And I think that has to be part of the discussion.
Well, thank you so much. And that actually closes out the time here we have for this session. Ken, Adam, Brett, I really appreciate your support. I mean, I think that one of the major themes from this certainly is we need to continue to educate the market, and we appreciate the role that, you know, academia plays, environmental NGOs plays, and project developers play in terms of that education. For those of you who are interested in interacting more with Ken on some of the work that is being done on Texas specifically, he will be doing a breakout session just coming up in a couple minutes. So I will kind of share a little bit about how those breakout sessions are going to work. But thank you again, panelists, Ken, Adam, and Brett.
We especially appreciate all the Global CCS Institute's doing on all these issues.
Absolutely.
Yep.
Thanks, everybody. So before I kind of go into breakout sessions, again, wanted to again thank all of our panelists over the last 2 days, as well as the U.S. Department of Energy, Office of Fossil Energy in USEA. You know, it was interesting. You know, I think that we have seen kind of throughout, particularly yesterday, you know, there were any number of presentations that talked about, you know, we're doing this modeling thanks to the work of the Department of Energy. We've done this mapping of geological storage thanks to the Department of Energy. Certainly, you know, I've said this in other events, and I'll say it here. I do think that part of the reason that the U.S. is leading globally on CCS is because of the leadership of the Department of Energy across carbon capture technology, geological storage, cost modeling that we see in presentations used around the world, not just in the United States, and, you know, kind of all issues in between. So again, thank you for their leadership, and thank you for USEA, who does also great work in terms of this education piece that we've talked about today in this session. Certainly, you know, it speaks to, if we want to grow to this 2,000 facilities that we need by 2050, we need to educate kind of the market and all the stakeholders about the opportunities in CCS. But again, this session's hopefully a little bit more practical. How do we get projects up and running? And so let's continue some of those conversations. So we're going to have 3 breakout sessions, as I've said previously. The breakout sessions will be in another platform, the GoToMeeting platform. There you can have your webcams going, you can have your mics off, and really have discussions with some of these panelists today. In the chat box, you should be able to see the 3 breakout sessions. And what you'll need to do is kind of copy paste those logins to go and listen to that breakout session. If you can't see that in the chat box or have any questions, certainly let me know. And our administrator will kind of stay on this session and answer any questions that are coming through in the chat box if you have an issue. Again, I will tell you, I'm managing one of those, so that's not, if you're going there and it's saying, please hold on and wait, it could be because, you know, Jeff and I, who need to kind of start those sessions, need to do that. We are going to give a 10-minute break, so those sessions will formally start at 9:45 Central. So you have kind of 10 minutes to, you know, take a bio break before you get started. But then those will be available. I did have questions about recordings. We will be recording the breakout sessions as well. And so we'll be recording the breakout sessions as well, and those will be available on our website. People did ask where you can find those events on our website, and I kind of posted there. So there's our events page, and that you'll see future events that the Institute is having, including that liability webinar. But then it's actually in another space on our website under our resources, our audio and visual library, and that's where you can find previous events. But everyone who both registered for this event and attended will get an email with links to that as well. Let me just check. I think there were kind of one more question. Yes. So yeah, we will keep this open for a couple more minutes so you can have access to that link. We won't close the webinar right away. We'll leave the webinar open until after we start that next session in case people are having issues or problems. But again, thank you everyone for attending the first sessions. We appreciate all the interactivity and all the questions, and you know, looking forward to engaging with you on the breakout sessions as well. Thank you.